Imagine a world without microchips, without advanced metallurgy, without even the wheel as we know it. Now, picture civilizations building structures that defy gravity, crafting mechanisms that predict celestial events with uncanny accuracy, and developing materials that outlast our modern marvels. This isn't science fiction. This is the astonishing reality of ancient technologies. Did you know that the Roman concrete used in structures like the Pantheon, built nearly 2,000 years ago, is in some ways superior to modern concrete, boasting self-healing properties that allow it to endure for millennia? Or that a complex astronomical calculator, the Antikythera mechanism, predates similar devices by over 1,000 years? Prepare to have your perceptions shattered as we dive deep into the ingenuity of our ancestors, proving unequivocally that they were not just advanced for their time, but often astonishingly ahead of it. Welcome to a journey through time, where we challenge conventional wisdom and uncover the hidden brilliance of ancient civilizations. We're often taught to view history as a linear progression, with each era building upon the last, culminating in our supposedly superior modern age. But what if this narrative overlooks a crucial truth? What if the primitive past held secrets and innovations that continue to inspire, perplex, and even humble us today? This exploration isn't just about dusty artifacts. It's about understanding the foundational principles, the sheer human intellect, and the profound impact these ancient marvels have had on our world, shaping everything from our architecture to our understanding of the cosmos. This documentary-style analysis aims to be more than just a historical recount. It's an educational deep dive designed to intrigue history buffs, engage curious minds, and provide students with a fresh perspective on the origins of science and engineering. We'll peel back the layers of time, examining how ancient solutions to complex problems often mirrored or even anticipated the challenges we face in the 21st century. Get ready to question what you thought you knew about human progress and discover the enduring legacy of forgotten genius. One of the greatest challenges in appreciating ancient technologies lies in our own modern biases. We tend to view the past through the lens of our present-day capabilities, often dismissing ancient achievements as rudimentary simply because they lacked the sophisticated tools and materials we now possess. This perspective, however, fundamentally misunderstands the nature of innovation. Ancient civilizations didn't have access to steel girders, microprocessors, or advanced chemical synthesis, yet they engineered solutions that were incredibly effective, durable, and often remarkably elegant. This common misconception stems from several factors. Firstly, the loss of knowledge over centuries means that many ancient techniques and methodologies have simply vanished, leaving us to marvel at the results without fully comprehending the process. Secondly, our focus on progress often leads us to undervalue solutions that don't fit our contemporary technological paradigm. We might see a simple lever system as primitive, forgetting the profound understanding of physics it represents, or overlook the intricate social organization required to execute monumental projects without modern communication. Furthermore, the sheer scale and precision of some ancient constructions, like the pyramids or Roman aqueducts, often lead to fantastical theories involving extraterrestrial aid, rather than acknowledging the extraordinary human ingenuity at play. This tendency to attribute complex ancient feats to external forces rather than human brilliance is a disservice to our ancestors. It prevents us from truly appreciating the depth of their scientific understanding, their mastery of materials, and their unparalleled organizational skills. By shedding these misconceptions, we can begin to see the ancient world not as a precursor to our own, but as a parallel universe of innovation, offering profound lessons for today. Let's embark on a detailed exploration of some truly mind-blowing ancient technologies, dissecting their ingenuity and tracing their impact on modern engineering and thought. These examples are not mere curiosities. They are testaments to human brilliance that continue to resonate across millennia. The Egyptian pyramids, particularly the Great Pyramid of Giza, stand as colossal monuments to ancient engineering prowess. Built around 4,500 years ago, these structures are not just piles of stone. They are precision-engineered marvels. The Great Pyramid alone consists of over 2.3 million limestone and granite blocks, each weighing an average of 2.5 tonnes, with some exceeding 80 tonnes. The sheer logistics of quarrying, transporting, and precisely placing these massive stones without modern machinery is staggering. Consider the precision. The base of the Great Pyramid is almost perfectly level, with an error of less than an inch across its 756-foot sides. Its sides are also aligned almost perfectly with the cardinal points of the compass. This level of astronomical and geographical understanding, combined with sophisticated surveying techniques, points to an advanced scientific knowledge far beyond simple observation. Theories abound regarding their construction, from elaborate ramp systems to water-based lifting mechanisms, but no single theory fully explains every aspect of their creation. This ongoing mystery only deepens our appreciation for the organizational power, mathematical acumen, and engineering genius of the ancient Egyptians. Their ability to mobilize vast resources and labor, manage complex logistics, and execute a project of this scale and precision remains a benchmark for modern civil engineering. Moving forward in time, we encounter the legendary Greek fire, a weapon that struck terror into the hearts of Byzantine Empire's enemies for centuries. Developed around the 7th century CE, this incendiary liquid could be projected from siphons onto enemy ships, burning fiercely even on water. Its strategic importance cannot be overstated. It was instrumental in defending Constantinople during critical sieges, effectively acting as a deterrent and a decisive weapon in naval warfare. The exact composition of Greek fire remains one of history's most tantalizing secrets. The Byzantines guarded its formula with extreme secrecy, and the knowledge was eventually lost. Historians and chemists have speculated about its ingredients, suggesting combinations of naphtha, quicklime, sulfur, and resin, but no modern recreation has perfectly replicated its reported properties. The fact that it could burn on water suggests a complex chemical reaction, possibly involving a component that reacted exothermically with water, generating intense heat and making it impossible to extinguish with conventional means. This level of chemical sophistication, developed over 1,000 years ago, highlights an advanced understanding of material science and chemical reactions that was truly revolutionary for its era, foreshadowing modern incendiary weapons and chemical engineering. High in the Andes, the Inca Empire forged an infrastructure marvel that rivals the Roman road network in its ambition and engineering ingenuity: the Capac Ñan, or the Great Inca Road. Stretching over 25,000 miles across some of the world's most challenging terrain, this vast system connected the empire's diverse regions, facilitating communication, trade, and military movements. What makes this achievement particularly astonishing is that it was built without the use of wheels or draft animals. The Incas engineered roads that traversed towering mountain passes, arid deserts, and dense jungles. They constructed intricate stone staircases, carved tunnels through solid rock, and built sophisticated suspension bridges woven from natural fibers that could span vast canyons. These bridges, some hundreds of feet long, were regularly maintained and rebuilt, demonstrating a profound understanding of structural integrity and material fatigue. The road system was not just a path, it was a meticulously planned network, complete with way stations, tambos, storage depots, and a rapid communication system utilizing relay runners, chasquis. This level of logistical planning, resource management, and adaptive engineering in such a harsh environment showcases an unparalleled mastery of civil engineering and project management, offering lessons in sustainable infrastructure development even today. While we often marvel at Roman arches and aqueducts, the true unsung hero behind their enduring structures is Roman concrete, or opus caementitium. Unlike modern Portland cement, which is prone to cracking and degradation over centuries, Roman concrete structures like the Pantheon and numerous harbours have stood for millennia, often submerged in seawater with remarkable integrity. Recent research has revealed the secret to its longevity: volcanic ash, pozzolana, and a unique self-healing mechanism. Modern concrete relies on a uniform mix, but Roman concrete incorporated small chunks of lime, which acted as hot spots during mixing. When cracks formed in the concrete, rainwater would react with these lime clasts, creating a calcium-rich solution that would then recrystallize, effectively healing the cracks. This self-repairing property, combined with the chemical stability provided by the volcanic ash, allowed Roman structures to withstand seismic activity and the corrosive effects of saltwater for thousands of years. This ancient material science offers profound insights for developing more durable and sustainable building materials today, proving that sometimes the old ways are indeed the best ways. Among the more controversial but equally intriguing ancient technologies is the Baghdad battery, discovered in 1938 near Baghdad. Dating back to the Parthian era, 250 BCE, 224 CE, this artifact consists of a clay jar containing a copper cylinder, an iron rod, and traces of an acidic agent like vinegar or wine. When reconstructed, similar devices have been shown to produce a small electrical current, around 0.5 to 2 volts. While its exact purpose remains debated, some suggest it was used for electroplating jewelry, others for medicinal purposes like pain relief, or even as a religious novelty. The possibility of ancient electrical technology is truly thought-provoking. If indeed it was a functional battery, it would represent an astonishing leap in understanding electrochemistry, predating Alessandro Volta's battery by nearly 2 millennia. This artifact challenges our linear view of scientific discovery and opens up fascinating questions about the extent of ancient knowledge in fields we typically associate with much later periods. Now, for the absolute pinnacle of ancient technological brilliance, an invention that truly redefines our understanding of ancient capabilities, the Antikythera mechanism. Discovered in a shipwreck off the Greek island of Antikythera in 1901, this corroded bronze device initially appeared to be a mere lump of metal. However, painstaking research over decades has revealed it to be an astronomical calculator of astonishing complexity, dating back to the 2nd century BCE. This intricate device, often referred to as the world's first analog computer, featured a complex system of at least 30 meshing bronze gears. It was designed to predict astronomical positions and eclipses with remarkable accuracy, tracking the movements of the sun, moon, and possibly even the planets. It could also calculate the dates of various athletic games, including the Olympic Games. The precision of its gear ratios, the differential gearing, a concept not seen again until the 16th century, and its ability to model complex celestial mechanics are simply breathtaking. The Antikythera mechanism's forward-thinking design is a profound testament to the ingenuity of ancient Greek engineers and astronomers. Its principles of mechanical computation, gear trains, and predictive modeling are foundational to modern engineering, clockwork, and even early computer science. It demonstrates a level of scientific and technological sophistication that was not replicated for over 1,000 years, forcing us to reconsider the entire timeline of technological development. This single artifact shatters the notion of ancient civilizations as merely primitive, revealing a deep understanding of mathematics, physics, and precision manufacturing that was truly revolutionary. It stands as a powerful reminder that genius knows no era, and that the seeds of our most advanced technologies were often sown in the distant past. In conclusion, the journey through these ancient technologies reveals a truth far more profound than simple historical facts. Ancient civilizations were not merely advanced for their time. They were, in many respects, astonishingly ahead of it. From the self-healing concrete of Rome and the unquenchable Greek fire to the vast logistical networks of the Incas and the astronomical precision of the Egyptian pyramids, our ancestors demonstrated an unparalleled capacity for innovation, problem-solving, and scientific understanding. The Antikythera mechanism, in particular, stands as a monumental testament to a level of mechanical and astronomical sophistication that challenges our entire perception of technological history. These aren't just relics, they are blueprints of genius, echoing through time and continuing to inspire awe and inquiry. Which of these ancient marvels blew your mind the most, or which other ancient technology do you believe was truly ahead of its time? Share your thoughts and theories in the comments below. Let's continue this fascinating discussion. If you're hungry for more insights into the hidden brilliance of the past, be sure to subscribe and check out our next video, where we'll delve into even more forgotten innovations that shaped our world. Don't miss out on uncovering the secrets of our ancestors.